Warning, the video you're about to watch contains mathematics at the level of pre-calculus. All material has an assumed prerequisite of college algebra and trigonometry. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video actually sits in any course. It doesn't have to be in a pre-calculus course or a college algebra course or an intermediate algebra course or algebra 2 course. It could actually be in a calculus course or actually any level, because there's no math here other than a little bit of transformations, and any algebra 2 student should be able to follow it. But students who've had me as their instructor for previous courses prior to pre-calculus already have heard my pitch for logarithms. They're my favorite function. But for the sake of those who have not had me as their instructor before, I'm going to clarify how important logarithms actually are. The reason why is because logarithms are how we as sentient creatures experience the world. This is just the graph, the base graph of a logarithm right here. So how does that mimic how we experience the world? It's just a curve. It doesn't seem like it should mimic it at all. But it turns out that our perception of light, sound, temperature, pressure, emotions, reactions, habits, and pretty much everything else we experience is logarithmic in nature. So let's see how this graph showcases our human nature. We're going to adjust it slightly by restricting the domain to only include arguments whose function values are at or above the horizontal axis. So I'm going to restrict the domain to just have x values that lead to the function values here. So basically I'm going to restrict to these x values. But then at the same time, I'm going to shift this function over just so that its x-intercept right here is at the y-axis. So let's do that right now. Doing that, we arrive at this. We're looking at actually the natural log of x plus 1. We shifted the natural log over 1 unit to the left. By the way, it doesn't have to be the natural log. I'm just picking on the natural log. And I'm also restricting the x values to just be from 0 to infinity. Now, the actual logarithmic base, like I just said, is not vital for this discussion. But what we're going to do is consider some representations for the horizontal and vertical axes. For example, the horizontal axis could represent the number of candies for a child, and the vertical axis would represent that child's happiness. More candy, more happy, right? 0 candy, 0 happy. Okay, so you might feel like, all right, I could buy into the fact that if a kid has never had candy, their happiness for candy is at a 0 level, but the more candy they have, the happier they get. Okay, I could buy into that. How hard, if the horizontal axis is how hard you slap a wall, pressure, right? And maybe I should call this hard, how hard you slap a wall. And the output could be the pain you experience. Well, if you don't hit a wall, then you experience no pain. But the moment you apply this amount of pressure to hitting the wall, your level of pain increases significantly. And if you double that, it increases more, but it doesn't double in pain. If you double the strength at which you hit a wall, it doesn't double your pain. If you had doubled that, for example, so I just hit with a pressure of level 2, but you go ahead and double that distance, or double that pressure, well, this is the level of pain that you feel, but that's actually not a doubling of the previous level. This is the pain for a level 2. Here's the pain for a level 4. Notice the actual difference between those is not that much. At some point, you're just hitting a wall super hard and it just hurts only a little bit more because you're already in a ton of pain. Now, those are more of a touchy-feely type of perception, but now let's talk about actual science. the level of energy emitted by all light sources in a room in watts per square meter. That could be your horizontal axis, right? So I will call that L for luminosity. And the vertical axis at that point could be represented by the perceived brightness. So I'll just say, I'll actually leave this P for perception. So if you have no light in a room, well, then you have no perceived lightness. If you don't have any energy emitted by light source, then you have no perception of brightness. But the moment that you have 1 lumen in a completely pitch black room, so you are sensory deprived, you're sitting in a cell, no doors, no windows, walls are completely solid, everything's very seamed up so that you can't see out light from outside. And then all of a sudden, your phone goes off. So the screen lights up. That would be a massive spike in perception for you. Now let's pretend that you're in your classroom. So I'm just going to make up a number here. And the number of lumens is like that. Okay. So you're in your classroom. And then all of a sudden, 1 extra lumen is provided because your phone goes off. Well, here's the difference in your perception. You're in a well-lit room. That is the perceived brightness to you. And then your phone, which could be in your back pocket, it could be on your desk upside down, whatever it is, it doesn't actually add that much extra light to the room. However, if you were just sitting there initially and your phone went off with 1 lumen and you were sitting there again in a sensory deprived room, even if that phone was in your back pocket or upside down on the desk or whatever, that light would be so bright, this would be your increase in perception. You would immediately see there's light. Wow. Right? So this idea could be applied to many other things like sound, the energy, level of energy emitted by all sound sources in a room. If you're in a sensory deprived room, there's 0 sound, and somebody drops a pin, which is, let's pretend, 1 decibel. It's not, but let's just pretend. Well, you would experience a huge shift in perception. Like you would have no sound, and all of a sudden you'd hear this ping, 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 right? But then you're in a room where there's a lawnmower going outside, it's 100 decibels, whatever it is, right? And then all of a sudden somebody drops a pin. I got to tell you, you probably wouldn't even have that much of a jump in perception. You wouldn't be able to hear it. And probably the saddest one is the last one. The number of times someone has done a specific type of drug and the perceived effect. The first time they do a drug, it's this huge perceived effect, whether it's a hallucination or some type of weird effect. They get this spike in whatever that effect is. But if they've done the drug 100 times, then the effect it has on them has, even though like this distance between having no drug and one drug and 2 and so on and so forth, even though those distances stay the same, once they go from the 100th time to the 101st time, the perceived increase in effect is actually not much. You need more to get the same level of output. And that is the human condition. We get acclimated to things. You get acclimated to the sound of the lawnmower outside your window. And so when somebody drops a pin, you can't hear it. You get acclimated to all the lights in your classroom. And so when somebody's cell phone goes off and it's on silent and it's in their back pocket, you have no idea that it just went off. If you hit a wall as hard as you can and you're in total amount of pain and then you hit it twice as hard, it still freaking hurts, right? It's not like it hurts twice as much. It doesn't. It just hurts. And if you've been taking drugs for years, it's never like that first time. And this is how we are as human beings. We love this way. We hate this way. We experience all the physical sensation of the world around us this way. The more you do something, the less effect it will have on you. And this is just a visualization of what I was just saying, which is that you have this initial kind of level where you're like, oh, I have one, whatever it is, right? One Tylenol, okay? And all of a sudden that pain, your happiness goes up by that much because the pain has gone away or whatever it may be. But then you have another one, and while it does get you to a second level of happiness, it's not as much of a jump as the first level was, right? It's the first level gives you this huge jump. The second level's not much higher than that. And finally, if just reiterating what I just said, but if you went from 100 Tylenol to 101, and I'm not saying in a single day, I'm just saying like if you've taken them every day for 100 days and then, it's helping, but it's not like the very first time when you really took away the pain. It only really adds that much extra to your level of happiness. Well, if that makes you happy, I have no idea if it does, honestly, but that's how we experience the world. We are logarithmic. You start dating someone. On your first date, they bring you flowers or something that you like, chocolate, whatever it is. Your happiness level spikes up because they cared, right? So you have this huge rush of adrenaline and endorphins, all that fun stuff where you're just like, yes, this person really digs me. And they do the same thing the next time you go out and you feel great about that. You're like, man, the first time they brought me flowers, this time they brought me candy. And the pattern goes on and on and on. You eventually commit to one another, and as is commonly the case, they bring you flowers. Perhaps this is the 1013th time. Do you think that your level of happiness will spike as much as it did the first time? I mean, if you're that person, no, I always get the same level of happiness spike every time I get the same gift. I think you'd be lying. You get acclimated to those gifts. Your logarithmic nature keeps you from appreciating the sentiment as much as the first time. We do this because we take advantage of people. Not that we are inclined to do that, but I'm just saying, like, you take, maybe not advantage, you take for granted individuals. You take for granted what becomes the norm and eventually get acclimated to it. So logarithms are totally who we are. We are so logarithmic in nature, and that's why I find logarithms to be the most beautiful of the functions.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Listen close, don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.